Hello everyone. We are Group 17 and we are going to be talking about aerospace materials and their special characteristics. Aerospace refers to designing, building, testing, and operating aircrafts within and beyond the Earth's atmosphere. Its significance can be seen in terms of global mobility, defense, exploration, and communication. All this would not be possible without the carefully engineered materials used in them. The field of material science plays a vital role in shaping the aerospace industry, and in this presentation, we will see how this is true.
Why does it not fly?
Well, actually, this is not a good paper airplane. There are many considerations in building an aircraft that flies properly. And one such consideration is the materials being used.
Yeah, in fact, the material selected have various characteristics that makes it appropriate for it to be an aircraft material.
Most important characteristic required for aircraft materials, which is strength. Materials used to construct key parts of the aircraft need to be able to withstand structural loads. They need to enable fuel efficiency, survive harsh environments, as well as maintain high safety standards. Now, how do specific materials help? Aluminum alloys contain elements like manganese and magnesium, which creates a solid solution. This distorts the atomic bonds, making it harder for the material to deform. Titanium alloys have an HCP structure, making it difficult for atoms to slide past each other, therefore increases resistance to deformation. Carbon fiber composites have a unique crystalline structure. The carbon atoms form long chain-like bonds, which are woven into parallel fibers, giving them immense tensile strength.
Aerospace materials also have to be as light as possible. This reduces the energy required to get the vehicles airborne, making them more economically efficient and use less fuel. Currently, carbon fiber is commonly used to make much of the aerospace vehicles more lightweight. Carbon fiber is lighter than most metals due to the low atomic mass of carbon, making them a good choice for the body of the aircraft. Another material that has been used to make aerospace vehicles more lightweight are polymer aerogels, more specifically polyimide aerogels. Aerogels are derived when the liquid component of the gel is replaced with gas without collapse of the structure of the gel. Hence, aerogels are mostly air and very porous, allowing them to be very light. Furthermore, they are also insulators. This allows them to act as a substrate material for antenna systems as well as co-ed insulation for aerospace vehicles without adding weight, improving performance.
Now I will share about high temperature resistance in airplanes. Airplane engines reach temperatures above 1000 degrees Celsius, so components must resist thermal creep, fatigue, and oxidation. Materials like nickel-based superalloys and ceramic matrix composites are commonly used in turbines and exhaust systems to survive these extreme conditions. At high flight speeds, aerodynamic friction also hits the aircraft skin. Since aluminum alloys lose strength above 150 degrees, high-speed aircraft instead use titanium alloys and carbon fiber composites to maintain strength and stability. High temperature resistance directly improves performance by allowing engines to run hotter and more efficiently, enabling faster flights and ensuring the structure remains safe and durable under extreme conditions.
Another important characteristic for aerospace material is that they need to be radiation and corrosion resistant. This is for the safety, durability, and performance of the electronics in the aircraft in extreme environments. With radiation and corrosion resistance, it also prevents the degradation of material and ensures structural integrity. Some material examples are titanium alloys, which serves as a protective coating layer. Graphene, which is chemically inert and immune to corrosion, has high electron density and mechanical properties, making it suitable for space varnish that helps shield aerospace hardware from the pressures of space. Polyethylene compounds are also a recommended choice for radiation and corrosion shielding, as they are chemically inert, which reduces corrosion and is high shielding efficiency.
And now let's talk about fatigue resistance, one of the most critical properties in aerospace materials. Every flight subjects aircraft to thousands of stress cycles from takeoff, turbulence, and pressurization to even landing. Without strong fatigue resistance, these repeated loads could cause cracks and potentially failures in aircraft. To prevent this, aerospace engineers rely on materials that can endure the stresses over long periods of time. Some of the most common ones include CFRPs, aluminum alloys, and titanium alloys. These materials not only prevent in-flight failures but also extend aircraft's lifespan, reduce maintenance needs, and enable a lighter and more efficient designs for aircraft.
Ooh, what's that?
Whoa, now I know why modern planes like those can stay up in the sky while being strong enough to travel to the fringes of the atmosphere, withstand extreme radiation, extreme temperatures, and still be durable enough to last a long time.
It's so interesting that modern planes use carbon fiber because decades ago planes only used carbon in the form of wood. This shows that materials may be made of the same elements but have various different properties.